Hi, my name is Keith Norbie. I work for SolidFire, and I'm here to do the Flash Decisions presentation that I've been doing for about a year now. I gave a variation of this presentation at the Indianapolis VMUG. We're here at VMworld 2014, and the theme of this is really all about how to understand Flash as a solution area for you to make decisions and get kind of an informed set of criteria and schemes to think through what you want to get, how you want to apply it, and some of those parameters. Of course, everyone knows Flash is fast. We're not breaking any news there. But the question is, how fast is it? And it's fascinating to really think about this because beyond just throwing a faster medium into an architecture, you have a lot of disk-based architectures that have been out for quite a while. And so the context between the traditional architectures that have been designed for disk, are orders of magnitude different from how much faster Flash is, and so the implementation revisions have been something to take note of because you have some choices you have to make in what you do. So this slide was contributed over a year ago by Justin Lauer in a Flash forum that I did in Minneapolis, and I love it because you got to bring it home from real life experiences of what you can relate for a Flash comparison. So as you have the standard, hard drive in terms of a read IOP versus a Flash read IOP, you've got roughly a factor of 375 times faster than what you get from disk as Flash. So for comparison, we got this guy here, Justin Baumgartner, and he's the guy from the Red Bull video that basically took a balloon up to the outer edges of our atmosphere and did the highest skydive ever. And he went so fast that he actually broke the sound barrier, and so that's fast. Free falling is fast enough. Breaking the sound barrier is really fast. So by comparison, walking is a little slower than breaking the sound barrier, especially skydiving. And so as the comparison of breaking the speed of sound versus walking seems like that'd be really, really fast, it still doesn't even look like the same difference between a hard drive and a Flash element. And the reason why that's substantially profound in an architecture is that as you put this in play, yes, it'll be faster. But as we're going to try to point out very quickly, is there's a lot of substance behind how you use that new medium and how you have to design ways for the ecosystem to plug into that medium and for it to be used in an at-scale environment. So as I go through, I basically describe a range of elemental areas and categories to look through. I won't go through all these here, but basically there's things you need to know about the types of Flash. Different drive types between MLC. There's a consumer grade MLC, there's an enterprise grade MLC, there's also an SLC, and these are designed for different applications in the environment. Some are designed to do garbage collection in the drive, some are faster, some wear longer, and know the differences there. There's different use cases in terms of where you put Flash for things like read acceleration, VDI workloads, database, etc. There's all kinds of affinity to VMware and the vSphere environment, as we've had to live through disk-based architectures with vSphere, something known as the storage blender, where you have IOs that get intermingled in a VMFS container. Flash fixes some of those things, so you don't have to do writes, realignments, and some of the things that you have with natural disk-based architectures. There's a lot of architectural differences. We'll get into those, as well as wear leveling, and we'll get into those as well. So if you look at, let's just take a look at the base element of what a Flash is. You have a package, and that's broken into 8 dies. And these dies then have basically 2 planes for the Flash to exist. And in those planes, you've got thousands of these blocks per die. And in those blocks, you've got roughly 256 pages per block. So that's where you have this difference between writes and erases. So as Flash comes in and it does writes at the page level, it does erases at the block level. And because of the difference in this architectural process, there gets to be a lot of things in the system that you have to do for how you clean that up in the back end. Also known as garbage collection, also known as recycling. And as you break the Flash shell down even further, you get into not just the different types of Flash and the types of different wear patterns, but you also get into things like performance cycles and where that matters. I think now we're in an age where we've seen multiple architectures prove out CMLC as something that is fully deployable in an environment because of the way you can architect it as a total system. If you look at Flash in general, the thing that's interesting to know is that they wear out. And I've got the picture of the eraser to really give everyone a context to the fact that if you have an eraser on a piece of paper, you can ultimately erase through the piece of paper at some point in time. In other words, there is a finite level of wear to a medium based on how you use it and how intensely you use it. There's a whole bunch of other details you can get into, but basically, writes are inherently expensive. That's what wears the media. Reads are technically free or much better, so to speak, for usage of Flash. If you look at garbage collection, it's probably the biggest component in terms of full resource impact to Flash itself. This is something that's important to understand because it tends to replicate through how a system deals at brute force, at blunt, with workload cycles in an array as you're trying to use this in an enterprise, especially an enterprise that is maybe an at scale or has mixed workloads. As you see this, you've got a process where you have, and this is just showing erase block 0 through 1, 2, and parts of 3. As you start to populate those pages in the blocks, you have a process where you have to basically copy over and write through. As you start to notice that as the write process over time becomes very fragmented through those pages, you have to go back through and you have to start basically rewriting and compacting and freeing up some of those pages and the blocks to be able to reclaim the space that you have in the full Flash cell. As this goes forward, again, this is a process that can be very system intense. Some default this again to the drive. Some have it up in the controller level as a process. And some use metadata ways to abstract this and be able to do processes in the back end to maybe write this differently in a way that is fundamentally different than just doing it to the drive level itself. And that kind of brings up right-click amplification. This is something that is a real degradation to the performance of Flash cell. So this is something to look at when you're trying to understand each of the architectures that you choose for Flash, because there will be different ones that will handle the right-click amplification better than others based on how they're systematically dealing with the wear leveling and the degradation process of that drive, how they're doing garbage collection. Again, are they trying to abstract and write fundamentally differently to the medium, or are they defaulting to the drive itself to do the garbage collection? And again, in some of those cases, you can roll through examples where that becomes a problem at larger scale. Fundamentally, again, we're looking at where does Flash show up then. We started out with a lot of PCIe-based Flash cards and disk-based arrays that had some levels of Flash encapsulated form factors like solid-state disk or SSDs. We now see them kind of littered through in terms of the hyperconverged and hybrid arrays. You've got SDN-based things that are scaling JBOD Flash or Flash arrays. You've got some inline accelerators, although the market ultimately has fundamentally really not adapted that. And then, of course, you have all Flash versus hybrid. And in that process, you have a lot of choice to make in terms of, where do you see value in placing Flash in the architecture based on your environment. So there's some choices to make. As you look at Flash and how it shows up, not just in the categories of a PCIe Flash card or an SSD card, and an architectural choice like a SAN array or a hybrid array or all Flash solutions. You've got things like system scale, redundancy. You've got the way the data is organized and how that pathing process happens. How do you deal through things like power outages, and how do you recover back from power outages in an all-Flash or hybrid system to be able to ensure not just that the writes are not compromised, but also what's the process and how does it repopulate the data through whatever its mechanisms are for the power protection loss. And there's really not any end to the number of choices that you have in the landscape of all-Flash choices. This is probably the hottest area. Part of the reason is that the cost of the Flash medium itself has come down to the point, along with some inline efficiencies that make Flash roughly at the price of disk. So you see disk being utilized for less and less in enterprise workload applications. And so you have choices about where that flash would reside if you go all flash. Some of those are in flash appliances. Some of those are in legacy retrofits. Legacy retrofits can be kind of complicated because you have array-based systems and the code that's been designed for milliseconds response times, queue depthing, things like that. Now you have flash operating at microseconds and some very highly intensive things that just can destroy an array. So there's been a lot of things that people have had to do in the legacy retrofits that some work better than others. Just make sure you crack that open and take a good look at what matters there. And of course, in the native all-flash arrays, you know, the three that I see show up most are SolidFire, Extreme IO, and Pure. There's lots of architectural differences between those. There's a tech field video out on this with Dave Wright, where he gives probably better information about all three than any of the providers himself. Obviously, Dave Wright is the founder of SolidFire, so he naturally will have some good things to say about that. But you know, you have choices here, and each one has specific design, fit, and criteria. So as you look at that, this slide I give props out to Chad Sakich. Chad's got a blog, virtualgeek.typepad.com, and he basically talked about the categorizations of all storage. This is important because as you start to see vendors coming to market with different architectural options, I layered flash into this in terms of how it shows up in the categories. You have clustered systems. These are typically scale up, but they're clustered controllers, and that category is fairly well defined for being able to, you know, update the system code and provide a pretty economical entry point for the SMB in the mid-market. You have loosely coupled scale out. You know, this is where you see vSAN, Scale IO, Nutanix, SimpliVity, Isilon, and others that will have flash littered into the architecture, but it ultimately is scaled out. It's loosely coupled. It's not defined by a tight, you know, interconnect, which brings us into the third category. That's where you see things like Extreme IO, where they're InfiniBand connected, and you're relying on some more of a very low latency, either proprietary or very high-end bus architecture to tightly couple the interconnecting nodes and the substantive flash processes or the flash resources that you'd have to write to and read from. And then you have the distributed shared nothing architectures. You know, this is where you can get into things like Atmos and Hadoop implementations, and there's a lot of things to get into there from an object store perspective. Software-defined storage has been a hot topic. Obviously, everyone's trying to apply their own definition to this, but you'll see a break between the data plane and the control plane. I think what you want to understand here and what you want to look at is that depending upon the virtualization platform and how you're trying to, I guess, bring a software-defined message into the storage layer, what kind of policy automation are you trying to drive from Flash and what Flash provides? So that Flash is not only just a workload, but it's a workload in the grand scheme of things like application tiers, a gold level, a silver level, and a bronze level. Each of those have different attributes that tie into how you would use Flash as that medium. And those will be definable attributes. In this case, you know, just showing some things that relate back to things you could probably naturally talk about in vVols. Ultimately, you know, it comes down then into at scale workloads that, you know, intermix between not just doing Flash for one workload and doing that silo fashion like a separate VDI all Flash workload and dedicating an array to it. That certainly is a lot of market adoptions. What I would argue is that you've got a solution where you could take you know, ways to mix workloads. And so at scale, I think that's the new opportunity to take a look for. You know, this is available for SolidFire and some others, but you know, this is really the cornerstone of where you take Flash in scale rather than just propagating islands or silos of workloads. You know, and that really reflects back into where all Flash really is going to have some different things that matter beyond just the medium itself. In the SMB and the commercial, you can see, you know, the full collapsing of workloads and one array or a couple of arrays doing the work of what you needed to have happen. At the number of workloads, and you start getting into the at-scale enterprise environments, that's where you're going to either have to fence off certain things and have separate silos, or look for architectural ways to be able to embrace mixed workloads at scale. And those typically get into controls. These are 5 things that I think matter. The things like, you know, how would you scale out for those types of environments? how do you fence off and guarantee workloads? That's another criteria that I think becomes important. How do you automate that management, not just in a GUI, but in a RESTful API or APIs that help you scale out an all-flash environment? How do you provide a high availability for those flash environments, especially as they would fail? And how do you do inline efficiencies? And several flash providers do this very well. They'll provide fixed or variable length block dedupe and compression and thin provisioning, and on and on. I'll skip past the QoS since we're out of time, and I'll just end with this note that not just myself, but there's plenty of community folks that have more information on not only flash technology, but how you apply flash technology into a VMware or other environments. As we're here at VMworld 2014, that's going to be something that might be high on the list of people that would want to know more information about how this layers into an at-scale or a VMware implementation. So you can ping me for more questions. There's plenty of community members you can plug into as well. And that's my vBrownbag section for VMworld 2014 around flash buying methodology. Thank you.